So yesterday our main concentration became taking our radicals and adding and subtracting them. Today the next logical step then is how do we go about multiplying and dividing. So our whole goal for today then is to be able to multiply and divide radicals. Dividing, we're only going to do part of the dividing today. Everything we do with dividing today is not going to be what we call rationalizing the denominator. We'll do dividing again tomorrow, where we're rationalizing the denominator, which is an additional step. But today we're just going to take care of kind of the regular dividing ones and how we go about multiplying radicals. So when you're multiplying radicals, I'm going to add a little caveat to this piece right here. I'm going to kind of scratch this out a little bit. And I'm going to say C times radical A times D times radical B. So we have stuff on the outside and we've got stuff underneath the radical. So when you multiply radicals, you multiply what's on the outside times what's on the outside. So this is going to equal whatever C times D is times your radical symbol, and then you multiply what's under the radical by what's under the radical. So this is going to end up being CD times radical AB. What's on the outside gets multiplied by what's on the outside. What's on the inside or underneath gets multiplied by what's on the inside or underneath. And then you have to simplify if you have to. Okay, so if we look at that first example, we've got radical 6 times radical 12. So we only have two things underneath. Now, if we were adding them, we couldn't add them because they don't have the same radical, but we're not. Multiplying, we don't care. Multiplying, all we have to do is take 6 times 12. Now, my suggestion is to do the multiplying first, then simplify. This is the square root of 72 then. 6 times 12 is 72. My suggestion is to do that first, now multiply. Now simplify. So if I simplify 72 divided by, I'm just going to pick a perfect square to divide it by to see if it works, and it's divisible by 36. I think it's 2 times 36. 36 is 6 times 6. So my 6 has a partner, so the 6 can come out, the 2 doesn't. So you get 6 radical 2. That's the way I like to do them. I mean, again, you could break 12 down to 2 radical 3, and then you're going to end up doing it again anyway. So multiply first, then simplify. Multiply underneath by what's underneath, and outside of by what's outside of. So if we look at the second example. Second example has 3 radical 5 times negative 2 radical 15. So I've got stuff on both the outside and underneath. If I multiply the outside times the outside, 3 times negative 2, that's negative 6. If I multiply underneath by what's underneath, 5 times 15, 75. Sounds like that's right. Yep. 75. Okay, so you got the first part of it done. Now we need to try to break the 75 down. Again, just looking for a perfect square. 3/4 is 75 cents. So 3 times 25. 25 is 5 times 5. So radical 75 becomes not 3 radical 5, becomes 5 radical 3. That has partners. but I have this negative 6 out there, so I need to multiply negative 6 times 5, which is negative 30 radical 3. And that's your solution, your simplified form of 3 radical 5 times negative 2 radical 15. Multiply outside by what's on the outside, multiply inside what's up the inside or underneath, and then simplify as you go along when we multiply. Okay, let's look at a couple special situations. If you have to distribute, it just goes back to the rules we've had before when we had integers. When you distribute, if I have radical 3 times, in parentheses, 5 minus radical 6, we have to distribute that radical 3 into both. So the 5's on the outside, so I just take 5 times what's understood to be there as a 1. So this just becomes 5 radical 3. Now I have to take radical 3 times negative radical 6. So 3 times 6 is 18. So that's minus radical 18. And now we have to simplify if we have to. So that's 9 times 2. 9 is 3 times 3. There's my partner. So I've got 5 radical 3 minus 3 radical 2. We go back to yesterday. We've got radical 3 and radical 2. To add or subtract, they have to be the same. They're not. That's your solution. Okay. Same rules apply that applied when we distributed before. Just now you have to do it with radicals. Okay. Why don't you go ahead and give number 4 a try. Make sure you FOIL it when you do this one. Yeah, take the first term of the first binomial times each term of the second, and take the second times each term. Give you about a minute and a half. Give that one a shot. Okay, take 5 times 4. 5 times 4 is 20. And we go 5 times 3 radical 2. So 5 times 3 is 15. So that's 15 radical 2. Now we go on the inside. Negative radical 2 times 4. That's negative 4 radical 2. And then negative radical 2, so negative 3 radical 4. Questions with that step? Now I have to simplify. If I look at this part right here, what's the square root of 4? Square root of 4 is 2, right? What's 2 times 3? 6. So this is actually negative 6 right there. I can combine these two because they have the same number underneath the radical. And I've got 20 minus 6. So 20 minus 6 is 14. 15 minus 4 is 11. So our solution to this is 14 plus 11 radical 2. And you're done. Okay. First, inside, outside, last. And in this case, that last term is going to just become a number because we know what the square root of 4 is. Let's go ahead and give this one a try, and I'll write it out for you. It's 4 minus 5 radical 6 times 4 minus 5 radical 6. Remember what it means to square something. It means to take it times itself. Now do the distributive property just like you did before to see if you can get this one. Okay, so your first step, 4 times 4 is 16. You got negative 20 radical 6, negative 20 minus 20 radical 6 plus 25 radical 36. Square root of 36, we know that is 6. 6 times 25 is 150. So we've got 16 plus 150 is 166. These have the same thing underneath. Oops. 20 minus 20 is negative 40. Radical 6. Oh, that's your solution and you're done. Okay. So multiplying radicals. They get a little bit harder and they get a little bit tricky when you have to start distributing in those. But again, just remember, use your same rules that you used when we were just dealing with integers or variables and simplifying expressions with different variables. Okay. Second part of today is dividing square roots. And dividing square roots becomes a number sense thing. The better you are at your number sense, the better you are at dividing square roots. The better you are at realizing what the perfect squares are, the better you are at dividing radicals. Today, the only ones we're going to deal with is we're going to work at simplifying and or just looking for perfect squares. So when you divide square roots, there's two ways I could write this. So the square root of a over b. Another way that this can be written is I can rewrite this as the square root of a over the square root of b. These two things mean the exact same thing. And depending on what the problem looks like, it depends on which way you want it to look. Okay. You want it to look like the first case if the fraction can be reduced, if they have a common factor that we could factor out of there. You want it to look like the second one if you realize that the denominator, the number on the bottom, is a perfect square. And remember our perfect squares: 1, 4, 9, 16, 25, 36, 49, 64, 81, 100, and so on are our perfect squares. And so we always have to be looking for these today. We always need to be looking for these perfect squares. And if you see the perfect squares like we do in this first example, we're going to rewrite this because both 49 and 4 are perfect squares. We're just going to rewrite this as the square root of 49 over 4. And then we're going to calculate what the square root of 49 is. Well, the square root of 49 is 7. The square root of 4 is 2. So the square root of 49 over 4 is the same exact thing as 7/2. Okay. Square root of 49 is just 7. Square root of 4 is 2. Okay. Now if we look at that second one, if you look at the second one, is 10 or 8 a perfect square? No, either of them are perfect squares. Is there a number that goes into both of them? Yeah, 2 goes into both of them. So I'm just going to kind of rewrite it. How many times does 2 go into 10? 5. How many times does it go into 8? Okay. Now if I look at this, is either of them a perfect square? The 4 is a perfect square, right? So now I could rewrite this as the square root of 5 over the square root of 4. So I reduce the fraction by dividing it by 2. Now I've rewritten it. Square root of 5, we have no idea what that is. Square root of 4 is 2. That's your answer. You're done. Okay. So sometimes you have to reduce. Sometimes you're just going to be given the perfect square. If you don't see a perfect square in the denominator, it means we're going to try to reduce. So if we look at the next one, we've got 3 radical 35 over 2 radical 20. 35 and 20 aren't perfect squares. So I'm just going to, this time instead of rewriting it, the 3 is just going to come along and the 2 is going to come along. What goes into both 35 and 20? 5, right? 5 goes into 35 7 times. How many times does it go into 20? 4 times. Now do we have a perfect square? Yep, we got a perfect square in the denominator. Square root of 4 is 2. So on the numerator, we didn't do anything. Square root of 4 is 2. 2 times 2 is 4. That's your solution and you're done. Okay. So though I didn't rewrite it this time like this, I still did the reducing and just left it in that mode because then I didn't have to rewrite it. Just saved myself some writing. But again, I'm looking for perfect squares. So if I look at number 9, are there any perfect squares in there? No. Is there a number that goes into both 50 and 2? What goes into both 50 and 2? 2. How many times does 2 go into 50? Goes into it 25 times. How many times does it go into itself? Once. What's the square root of 25? 5. 5 times 3 is 15. What's the square root of 1? Just 1. So 15 over 1. So that ugly thing, 3 radical 50 divided by radical 2, the answer is just 15. That's all it is. Let's look at number 10. Do you see a perfect square? Yeah, there's a perfect square right there. Don't need to do anything with the numerator. What's the square root of 4? It's 2. 2 times 5 is? There's your solution. Okay. So the key when you're dividing today is first look for perfect squares, specifically in the denominator. Because what you're going to find out tomorrow is we can't have radicals in the denominator. Today you shouldn't end up with any. Specifically look to see if there's a perfect square in the denominator and then fix it. If there's no perfect squares, look to reduce the fraction that's created. Okay? So that's what you're going to do today. You're going to look at multiplying and you're going to look at dividing as far as rational expressions. Worksheets inside Schoology.